Okay, we are going to solve two trig equations. First one is on the screen as follows. So what is the first step that we want to do before we even get started in this problem? We actually want to factor out a cosine as a GCF between the two terms. So we would have 2 cosine of x minus the square root of 3 in parentheses left over. And at that point in time, we're going to use the zero product property and find when cosine of x is equal to 0 and when 2 cosine of x minus 3 is equal to 0. When is cosine of x equal to 0? It happens twice at pi over 2 and 3 pi over 2. And the second factor, when I start to solve, I'm going to get a problem where cosine of x is equal to square root of 3 over 2. The reference angle for that is pi over 6. So that's the angle in the first quadrant. What other quadrant is cosine positive? The fourth quadrant, so our reference angle for pi over 6 would be 11 pi over 6. So we actually have 4 answers. 2 here and 2 here. Our second equation starts with 4 sine of x minus 3 equal to 0. So our first step is to add 3 to both sides and then to divide by 4. So we need to figure out when the sine of x is equal to 3/4. What do we need to do in order to find that? So we're going to go to our calculator and we're going to do the inverse trig. And if you're in radians, you'll find that your calculator is equal to the inverse sine of 3/4 has a decimal of 0.84. So that means 0.84 radians. So that's the angle in the first quadrant, 0.84 radians. What other quadrant is sine positive? So we're in the second quadrant and we need to have 0.84 radians left over as a reference angle. So what do we need to do to find that? We are going to take pi minus 0.84 and we are going to get 2.294 as an answer. So we have 1, 2. Now, if you look at the domain of this problem, are those the only 2 answers? We need to actually understand that this does not restrict for just one period worth. So it's going to be 0.84 plus 2 pi r and 2.294 plus 2 pi r because it's an unlimited domain. So it's going to be every new circle to infinity. And that's how you solve 2 trig equations.